Okay, this is our last circle geometry lesson. There are only 4, because there's only 4 properties we're talking about. And so the last property we are talking about is tangent property. And so if you haven't done so yet on your word wall, you should add a tangent line. And on your tangent line, you should also label a point of tangency. And so what is a tangent line? Well, hopefully you've looked that up and filled it in for yourself. I will summarize for you. So basically what a tangent line is, a line that touches a circle at exactly one point. Another thing about a tangent line is it is perpendicular to the radius at that point. So at the point that it touches the circle, it is at exactly a 90-degree angle with the radius or the diameter of a circle. So through any line passing through the center of a circle. And so this point has a special name, and this is called the point of tangency. Hey, I know on my line it looks like it's touching for a little bit, but basically there's only one point, and so that point is perpendicular. My shadow is blocking the center. There we go. Okay, so either side doesn't matter. Obviously, both sides of perpendicular lines are 90 degrees. Okay, so then it says, well, let's find the missing angles if we know that T is a point of tangency. So basically it's saying T is a 90-degree angle. Well, if one side is a 90-degree angle, the other side also is a 90-degree angle on a straight line, right? Thinking a straight line, this whole would be 180. So each half would be 90 degrees. If we're looking at B, B has formed a triangle, so we have a point of tangency, so we know that that angle is 90 degrees. And then you have X. Well, hopefully you remember all the angles in a triangle have to add up to 180. So to find our missing angle, we're going to start with 180 degrees and start taking away the angles that we do know. And whatever's left over will be our X. And so when we subtract, we get 41 degrees. Nice and simple. You have to remember that a point of tangency will be 90 degrees. Just like in example B, it won't always be drawn in for you. Okay, next example. So O is the center of a circle, the origin. And point B is a point of tangency, so we know that it is 90 degrees. Determine the values of V and W. So remember, either of these could be 90 degrees. And we're going to find these two angles the exact same way we found the last angle. So V is going to be 180 degrees, take away 90, take away 32. And so for V, we get 58 degrees. And for W, we should get, we use the same process. So W equals 180, take away 90, take away 60. And hopefully you notice that whenever you have a right triangle, you're always taking away 90-degree angle to start. So you could just jump straight to just thinking 90 take away 60, since half of 180 is 90 anyways. And so W is 30 degrees. And so from this, we could actually determine that this length, A to B, and B to C, are not the same lengths. And so I'm curious to see if you can tell me why that they would not be considered the same. So if you can tell me that tomorrow, maybe I'll give you a little bonus. Okay, again, we have O is the center of the circle, so origin, and point G is the point of tangency. So if it's a point of tangency, we know that it is a 90-degree angle. And so we want to find the missing length. So again, we have a right triangle. We know a couple of the side lengths. I hope your first thought is, let's use Pythagorean theorem. Okay, so in this case, A is actually the hypotenuse. So I'm going to call it hypotenuse because that's, otherwise we have a bunch of A's going around and it's just confusing. And so when we're looking for the hypotenuse, we add the two smaller squares. So 28 squared plus 22 squared will give us the hypotenuse squared. And so 784 plus 484 gives us the hypotenuse squared. Opposite of square is square root. After we add those, I always forget to add them. And so when we square root our answer, it is not a perfect square. So we need to round to the nearest tenth, and we get 35.6 is the length of the hypotenuse, which is A. Wow, I'm changing letters all over the place here. I'm going to go back. Okay, so in the question it asked us about A, but we were saying it as the hypotenuse. So we were using H. So just if you're going to change the letters you use to make it more clear, you just need to communicate that. Okay, now we have a bunch of triangles going on, and this will usually happen. And so what I want you to notice is that we have a radius line coming to a point of tangency, so we know that that's going to be at 90 degrees. And then we have a chord line coming to the point of tangency, and that will not make a 90-degree angle. It's only when you have the radius or diameter line touching the point of tangency that it will be at a 90-degree angle. So in the diagram it says AB is a tangent at point D, so D is the point of tangency. BE contains a diameter line of FE, and angle ABE is 50 degrees. So angle ABE, so that means starting at A and going to B and ending at E is 50 degrees. So then we need to find the missing side lengths. Okay. Oh, pardon me, missing angles. So, angle, let's start doing some color coding here. Angle BDC, so B to D to C, we already said is a 90-degree angle because it is a point of tangency with a radius line. If we look at DCE, can we find DCE? Oh, we won't go to DCE just yet, just kidding. We need to know a little piece, so before we can go to DCE, which is this angle, DCE, I want you to think of a straight line. And so this side of the straight line is 180 degrees, and the other side of the straight line is also 180 degrees. So whatever this missing angle is, plus this missing angle, will have to equal 180. The other thing we should notice is that that missing angle is part of a triangle. Okay, so this angle is going to be 180, take away 90, take away 50. And so we get an angle of 40 degrees. So that means whatever the other side of the angle to make that straight line has to make it add up to 180. And so we get 140 degrees. So DCE is 140 degrees. And then the last angle we have to find is DEC. I'm going to have to erase a little bit here. Okay, so the other angle, they're DEC. So they're looking for this angle here. Okay, well this takes us back to, I think, the second lesson. And so I hope you notice that we have two radius lines. So that means they're going to be the same length. So that means those angles will be the same. And so this is 140 degrees. And so these two angles have to share the remaining amount to make 180. And so that remaining amount is 40 degrees. So this is going to be 40 degrees divided by 2. So 20 degrees. So in here we have 20, and in here we have 20. And that's because we have an isosceles triangle. And so it says, what type of triangle is CDE? Well, this green triangle is isosceles, because it has two side lengths that are the exact same, and so two angles that are exact same. Okay, I haven't really asked you to do too much on your own yet, so I am going to leave you with this one to try on your own. It is a little bit tricky. I do want you to notice that there is an equilateral triangle here, and equilateral triangles have three lengths that are all the same, and they also have three angles that are identical. That is the only hint I am giving you. Give this one a try, and we will check it together in class tomorrow.